Composite of functions. F of g, or FOG, reads as f of g. So if we have f of g of x, that means we are going to have f of g of x. So the g will be in replace of the x for f. So what you're going to do is substitute the inner function into the outer function. Let's work on some examples. Okay, we have two functions, f of x and g of x. And the first thing we are going to do is find f of g of 9. So this one we are actually inputting a value instead of just an x for our x. So this is just f of g of 9. So what this is we're going to plug 9 in for g. Whatever we get here, we're going to plug that in for f of x. So g of 9 is 9 minus 4, which is 5. So this actually will be f of 5. Okay, see the g of 9? Well, g of 9 is 5, because we took 9 minus 4 is 5. So f of 5 is 2 times 5 plus 1. 10 plus 1 is 11. So f of g of 9 is 11. This video. Okay, I will show you another way to work this instead of all the clutter up here. So we take g of x, okay, the g of 9, actually g of 9, not x, and we go 9 minus 4, that's 5. Then we still have f to take care of, so f of 5 is 2 times 5 plus 1, which is 11. Okay, or you could take g of x and place that in for x, but that I'll show you that here pretty quick. Let's look at f of g of x now. So that's with the numbers. Usually you will come out with a number. Now f of g of x, we are going to take g of x, which is x minus 4. So that's actually f of x minus 4. So what you're going to do is whatever g of x is, you're going to say that's f of x minus 4. Then you can plug that into your f. So that x minus 4, we're going to replace this x with this value. And then we have 2x minus 8 plus 1. So that's 2x minus 7. So this is pretty much right here and on. This is pretty much evaluating functions, especially when you had a value other than x or a plain number. So let's look at g of f of x. So g of f of x. So rewrite this, except instead of f of x, we are going to write in the value or that function. So that's 2x plus 1. Okay, g of 2x plus 1. So whatever this is, you're going to replace it with that function. Then you're going to evaluate g with this value, which would be 2x plus 1 minus 4. So this value, x minus 4, instead of x, we're going to go 2x plus 1, and then we'll have 2x minus 3 as your value. The composite of functions takes a while to get used to, especially going from numbers to values or just an x. So the same two functions And this time we are going to evaluate g of f of -2. We want -2. So I always rewrite this as g of f of -2. I always like this way because what you're going to do is evaluate from the inside going outward. So f of x is 2x minus 1, but we are going to replace the x with a 2. So this is like evaluating functions again. You just have to use the correct function. So now we have f of -2 is -5. We're going to plug that -5 into the g. So our answer is -9. F of x equals 4x minus 5, and g of x equals 3x plus 2. So let's go ahead and go f of g of x. And I like to write it as a subset, or in this format. I always think this is like a subset. Not like the mathematical term subset, but it's like a nest. So first we have f of g of x. Well, we have no value for x, so what we're going to do is replace this g of x with the 3x plus 2. So instead of g of x here, we have 3x equals 2. Then we have to evaluate f at 3x plus 2. So f of x is 4x minus 5. This little guy right here is going to replace the x. So we'll have 4 times this value of 3x plus 2, and then minus 5. So we have 4x minus 5. Instead of x, we have the value here. And then we are going to distribute and add like terms, and we get 12x plus 3. So f of g of x equals 12x plus 3. So we are more or less evaluating a function in a function. Okay, g of f of 2. G of f of 2. So now we have a number, and our f of x is 4x minus 5, and we need to input a 2. So evaluate f at 2. 4 times 2 minus 5, so that's 8 minus 5, which is 3. So f of 2 equals 3. F of 2 equals 3. So in place of f of 2, we are going to place g, or 3. G of 3. G is 3 times x plus 2. So instead of x, we are going to place that value. And all we're doing is just evaluating functions. And g of 3 equals 11. So our g of f of positive 2 equals 11. If we have f of x equals x squared minus 2, and we have g of x equals x minus 1, we are going to find f of g of x, or in this case, this format, which turns out into this format. I'm just so used to writing it in this form. So f of g of x, so g of x is x minus 1, and then we are going to input this x minus 1 into our f function. So we have x squared minus 2. This, you cannot distribute that 2. Do not distribute that 2. What we're going to do is copy and paste and FOIL, unless you know the secret trick to this one. X squared minus 2x plus 1 minus 2. When you FOIL this out, it's going to be x squared minus x plus 1. So the negative x plus negative x is that negative 2x. Then we have 2x x squared minus 2x minus 1. So that will be our answer. This concludes this video.